Okay, my friends, this video is 5.2. I guess it probably will be 5.2a, since there'll probably be two videos on this section. And I think these guidelines are super, super helpful. What's going to happen is they're going to give you an equation. They're going to tell you what it should equal, and you have to make it equal that eventually. The key that you need to remember, and I know you're very trained on this, is that you're trying to show that it's equal. You don't know that it's equal. So you can't add something to both sides. You can't work on both sides at the same time. You cannot multiply both sides by 2. You cannot add 5 to both sides. You cannot divide both sides by 3. What you've been trained to do to one side and the other side, the same thing, you cannot do. You do what you did in the last section to one side of the equation to make it equal the other. And if you get into a dead end, you can then work the other side. So again, one side of the equation at a time. What I'm trying to tell you is that you cannot use basic algebra and add to both sides or subtract on both sides because they're not telling you it's equal, you're showing that it's equal. So it's like an equal question mark, you know? It's like a maybe it's equal. It's often better to work with the more complicated side, try to make it less complicated. Because you notice that we had some crazy things that just boiled down to tangent of x, or crazy things that just boiled down to sine of x. And they're telling you what your goal is. So these are the things that we've kind of already talked about. Look, it's not new. Factor, add fractions, square something, or create a monomial denominator. What does that mean? A monomial denominator means a denominator. This is not a monomial denominator. That's a binomial, 1, 2. Monomial denominator is like this. Okay? 1. So these are the things you're trying to do. Look for opportunities to use the fundamental identities. We call them the golden, often. The golden identities. They're right here on the whiteboard in my classroom. Sine squared x plus cosine squared x equals 1. And then we change that. Look for what you're trying to find, so the expression you want, which is going to be the right side usually, what it's going to equal. Sines and cosines, change everything to sines and cosines. They're telling you what pairs up, which is basically off the whiteboard. And that's pretty much, that's a lot of it. When it doesn't work, just change it all to sines and cosines. I like this one a lot. Sometimes people do this too early. So when it doesn't help, so when this doesn't help, change everything to sines and cosines. Step 5, I don't know that they needed to say it, but I'm going to say it again. Always try something. Even making an attempt that leads to a dead end can help. And as you notice, when I'm doing these, I don't really know what to do. Sometimes there's 2 routes you can go. They both work. Sometimes there's 3 routes you go, and 2 of them don't work. So let's just start. You see how it's basically what we did before, but it tells you kind of what the goal is? The goal is sine squared of x. So let's work on the left side, pretending that we're just working on the left side. And I'm kind of just going to emphasize for now that we can only work on one side at a time. So what looks good on this one? I see the secant squared minus 1, and I feel that that's one of these identities. I feel that secant squared minus 1 is tangent squared. So I'm going to replace this with tangent squared of x. And I'm going to leave alone secant squared of x. And then I have to wonder if those were changed into sines and cosines, if they would be easier to, if something would cancel, right? Because tangent's got a couple sines in it now and a couple cosines. Secant's got a couple cosines, right? So let's just look at that. So we haven't done anything to the right side. We're hoping that this is equal, question mark, right? And tangent is sine of x over cosine. So this is sine of x squared over cosine of x squared, or sine squared of x over cosine squared of x. We're going to divide that. I put a big fraction line, 1 over cosine squared. What do you think is going to happen when we flip that cosine squared? What's this going to all equal? When we multiply and flip that cosine squared, it's going to be a really good thing for us. It's going to be awesome. What's going to happen is it okay if I just kind of like move it up here? If I just multiply by the reciprocal, basically. So instead of dividing by 1 over cosine, I'm multiplying by cosine over 1. Cancel, cancel. That's what I have. Okay? Let's take a second and look at what was over here. Sine squared of x. So what do? We just kind of put this down. This is kind of what you're doing. I changed it to an x. And then you're kind of like, yay, I did it. 5 equals 5. Sine squared of x equals sine squared of x. That's good. That's what we want. So in a way, a lot of people like these better because at least it tells you what your end goal is. But what I just want to be really careful that you don't do is to work both sides at the same time. You can work on one side and then give up and work on the other side, and it might work out. That's fine. That's actually a technique. But generally, you just want to be careful not to add something to both sides, etc. So why don't you try this one right here at your desk and see how you do. Or if you're watching online, pause the video and give this problem a try. Verify this identity. So obviously, you're not going to change the 1. So you're going to focus on working, I think you're going to focus on working on this side of the equation. See if any of that makes sense. If you have a fundamental identity or you can change the sines and cosines, that's always a good idea. So we're just going to pause and try this problem. Okay, friends, so again, make sure you pause the video and try this problem. The answer will appear in just a moment, so please, please give it a try. Okay, so here is what happened. We changed sine squared plus cosine squared equal to 1 because this does in fact equal 1. And then we had cosine squared, and I changed secant to 1 over cosine. I noticed that that's just cosine squared over cosine squared, right? Top times top, bottom times bottom. 1 over 1 is 1, and 1 is 1. Check mark. We did it. Okay? That's pretty much what we're trying to do. In a way, it's nice because it gives you an end goal of what you're trying to get to. They get a little more complicated, but they don't get any more complicated than what you did in the last section, in my opinion. If you look at this, it's basically a problem from the last section. And what side do you think is more complicated? What side do you think we're working on? We're working on the right side this time, right? It's basically a problem from last night's homework. So what I'll do is I won't cross this. Sometimes people call this like the midline or whatever. So I'm just going to keep on doing this. 2 secant squared of, I'm going to make it x. 2 secant squared of x. Okay. I'm just not doing anything over there. Let's try to work on the right side. I'm going to go a little faster because potentially you saw this on home enjoyment before, and you might have seen it when we went over it today. I think this is what we got to do. You kind of see this 1 plus sign or this 1 minus sign or this 1 plus cosine or this 1 minus cosine. It's supposed to be a dead giveaway. It's kind of be, pretty clear what's happening there. So what happens is I get this 1 plus sine of x plus 1 minus sine of x all over. And when I FOIL this out, which is going to be the same on both sides, these are the same, I'm going to have 1 minus sine squared of x. Do you see anything on the top that's kind of nice? Good news on the top, right? That cancels, that cancels. So I now have 2 over 1 minus sine squared of x. And we just got to keep moving. So what about 1 minus sine squared of x? What's 1 minus sine squared of x? This is definitely something you want to know. If you've been getting by and just waiting for me to say it, you just definitely want to know this. So 1 minus sine squared of x is cosine squared of x. I like to keep going down rather than sideways for these problems, just in case. It just seems like a little bit weird to not do that. So basically now you have 2 over cosine squared of x, and you know that you can pretty much, cosine's reciprocal is secant, so this is 2 secant squared of x. And this is also 2 secant squared of x, and we're done. That's it. That's what you have to do. So hopefully that made some sense. I'd love you to pause the video and give this problem a try. It's very similar to the last one. Which side do you think you'd work on? Just ask yourself that question. Leave the other side alone for a little bit and see if you can get the right side, to equal the left side. So try that, and we will reconvene shortly. Okay, so we're continuing on with this section. If you were in the video, I'm going to try to splice these videos together because I accidentally stopped recording. So hopefully it worked out. But this is the last problem I asked you to pause and try. I want to get through, I think, one more example, and then we will wrap this up. So I'm going to go on. I know this is kind of quick. Luckily, at least, it's all recorded, so you can go back to it if you need. Slow it down, speed it up, whatever you got to do. Let's look at this one. What side looks more difficult, the left side or the right side? The left side, right? So I'm just going to see, can I pull this from one of my identities? So again, every time I do this, I'm looking at the whiteboard in my classroom. And I know that on the whiteboard in my classroom, it says that this is equal to secant squared of x. If you don't know that this is equal to this, I would suggest you study it like ASAP. And then this is cosine squared minus 1. A little weird. This is actually negative sine squared of x. That one I could see tripping some people up because it's in the wrong order. So like if you rearrange this, you have to move the sign over here and the 1 over there, and you'll get negative sine squared of x. This is pretty good. We're hoping that this will eventually equal tangent squared of x. We're hoping this will eventually equal tangent squared of x. Notice how I do not do the same thing to both sides. I do not touch the other side. I just leave it alone. So secant is cosine's reciprocal. So that's 1 over cosine squared of x. And sine is still just, I guess I could just put that up here now, right? You see it? That's really good because what is sine over cosine? Tangent. So I have negative tangent squared of x. Always write this last step. Equals negative tangent squared of x. And that's it. Okay. So again, we want to have you pause the video and try one more of these. Sorry for the speed at which we're going on this. I know we're going a little quick. Hopefully these are skills that we've already built in the last section, and we're just trying to work one side to equal the other. So if you could pause the video and try this problem whenever it loads. This guy. And then we'll kind of wrap. So if you could try to verify that identity, I'll put the answer up in a moment. And then, actually I won't even put the answer up because there's multiple ways to get there. The answer is when they equal each other, right? So there's multiple ways you can get there. So I'm just going to cut it here. Pause the video, give this a try. I'll see you in the next video. Peace.